Questions 11 through 20 of the 1998 Grade 8 Gauss Math Contest is what I will cover in this video. The weight limit for an elevator is 1,500 kilograms. The average weight of the people in the elevator is 80 kilograms. If the combined weight of the people is 100 kilograms over the limit, how many people are in the elevator? So the average weight is 80. So let's say there are n people in the elevator. If the average weight is 80, that means the total weight is 80n. Total weight. And they're saying in this question that the combined weight, total weight, is 100 kilograms over the limit. So the limit is 1,500. So that means that 100 kilograms over that is 1,500 plus 100, which is 1,600. And that is equal to 80n, which is the combined weight of the people. So we just solve this equation. Therefore, n is equal to 20. So there's 20 people in the elevator. So the answer is D. In the 4x4 square shown, each row, column, and diagonal should contain each of the numbers 1, 2, 3, and 4. Find the value of k plus n. So let's draw this out without the letters. And first let's fill in what they give us. They give us 1, 2, 3, and 1 over here. And I think those are the only numbers, right? Okay, so we have to start filling this in, and it kind of reminds me of Sudoku, that game. I'm sure you've heard of this very famous game, Sudoku. Anyhow, so the key is that each row, column, and diagonal should contain the numbers 1, 2, 3, and 4. So the diagonal here, right across there, is 1, 2, 3. So that means this has to be a 4. And that's the only easy one they've given us. Well, let's look at this row here. We only have 2 and 3 missing, but I can't put a 2 in here because there's already a 2 there. So that means the 2 has to go there, and therefore the 3 goes there. All right, so far so good. So now let's look at this column. We have a 1 and a 2 already. We need a 3 and a 4. I can't put a 3 here because there's a 3 there. And 3s are not allowed more than once, right? Or any number is not allowed more than once in the same row or column. So the 3 has to go here. And therefore, the 4 goes there. And similarly, if you look at this row, we have 1 and 2 to put in. So 2 cannot go here because we already have a 2 there. So that means the 2 has got to go here, and therefore this is a 1. All right? And if we look at this column, we already have a 2 and a 4. We're missing a 1 and a 3. A 1 cannot go there because we already have a 1 there. So therefore the 1 has to be there, and this is a 3. And I think that finishes the question because they wanted us to find k plus n. This is k and this is n. So this is k and this is n. So k plus n is 1 plus 2, which is 3. And therefore the answer to this question is B. Claire takes a square piece of paper and folds it in half 4 times without unfolding, making an isosceles right triangle each time. After unfolding the paper to form a square again, the creases on the paper would look like. Just get out a piece of paper, get out a square piece of paper, or make it into a square, and then fold it 4 times and open it back up. That's what I did. And you're totally allowed to do that on a math contest. They give you paper and you can fold a paper. No one is going to stop you from folding a paper And that's how I would do it. And if you do, you'll find that the choice that is correct is choice C. It's going to look like that. Stephen had a 10 a.m. appointment 60 kilometers from his home. So this is his home, and he had to travel 60 kilometers, and he was supposed to get there at 10 a.m. He averaged 80 kilometers per hour for the trip and arrived 20 minutes late. So he arrived at 10:20 a.m. At what time did he leave his house? All right. So 80 kilometers in 1 hour is the speed he's traveling at, and his distance is 60 kilometers, and we want to figure out the time. So x hours. This is 1 hour. That's basically the equation. Now, if we get rid of the hours and the kilometers, we get 80 over 1 is 60 over x. And if you cross multiply, you get 80x is equal to 60. And therefore, x is equal to 60 over 80 hours. And this, of course, is 3 over 4 hours. So 3/4 of an hour is 45 minutes. So that means if he arrives at 10:20, he left 45 minutes before that. So 45 minutes before 10:20 is 9:35 a.m. And that would be choice A. Michael picks 3 different digits from the set 1, 2, 3, 4, 5 and forms a mixed number by placing the 3 digits in the spaces of these 3 boxes. The fractional part of the mixed number must be less than 1, for example 4 2/3. What is the difference between the largest and smallest possible mixed number that can be formed? All right, so we have 1, 2, 3, 4, and 5 as our possible choices, and we want the largest mixed number and we want the smallest mixed number, and then we're going to subtract them. So let's make the largest possible number with these choices. Well, the largest whole number is 5, and then if that's already been taken, I've got these 4 numbers left, and I want to make, again, the largest possible, and I think that would be 3/4. Because I can't put 4 over 3 because it says the fractional part must be less than 1. So as tempting as that is, that's not allowed. And then the smallest possible number I can make from this set, a fresh set of course, we can use these numbers again. The smallest whole number of course is 1. And then from the remaining 2, 3, 4, 5, the smallest fraction is going to be 2 over 5. So this is the largest, and this is the smallest possible numbers that I can make according to the rules of this question. And therefore, if you do the math, this is 5.75, and this is 1.4, and therefore this is going to be 4.35. And let's see, 4.35 is which of the following here? This is, I think it's 7 over 20, this one. Yeah. 7 over, because this is 35 over 100. And if you divide top and bottom by 5, you would get 7 over 20. So, yeah, E. Suppose that x star means 1 over x, the reciprocal of x. For example, 5 star is 1 over 5. How many of the following statements are true? All right, so we've got to go through these statements. All right, let's go through them. The first one, 2 star plus 4 star is 6 star. Okay, so 2 star is 1 over 2, 4 star is 1 over 4, and if you do the top and bottom, you'll get 3 over 4. Is that equal to 1 over 6? Right? Because that's what 6 star is. And the answer is no. 3 over 4 is not equal to 1 over 6, so this is not true. Put a little X there. The next one is 3 star times 5 star is equal to 15 star. So let's see what this gives us. 3 star is 1 over 3, 5 star is 1 over 5, and therefore 1 over 3 times 1 over 5 is 1 over 15, and that is indeed equal to 15 star, which is 1 over 15. So this is correct. Now let's try the third one. You've got 7 star minus 3 star is equal to 4 star. So we've got 1 over 7 minus 1 over 3, and this looks like common denominator is going to be 21, and we're going to have 3 minus 7, so this gives you minus 4 over 21. And is this equal to 4 star, which is 1 over 4? And of course it is not. So that is incorrect. And then we've got one last one, which is 12 star divided by 3 star is equal to 4 star. So 1 over 12 divided by 1 over 3, and you would invert and multiply like that, and this gives you 3 over 12, which is 1/4. And is that equal to 4 star? It is. So therefore this one is true. So how many of the following are true? Well, it looks like this was true and this was true, so 2 of them are true, so therefore the answer is C. In a ring toss game at a carnival, 3 rings are tossed over any of the 3 pegs. A ring over peg A is worth 1 point, a ring over peg B is worth 3 points, and a ring over peg C is worth 5 points. If all 3 rings land on pegs, how many different point totals are possible? It is possible to have more than 1 ring on a peg. Okay, so we have to figure out all the possibilities. Well, if you look at it from sheer probability, the first toss can land in any of 3 positions. So you've got 3 possibilities. The next toss can land in, again, any of 3 possibilities. And the third toss can also land in any of 3 possibilities. So 3 times 3 times 3 is 27. So there's 27 possible outcomes. And we have to very quickly write them all out. So we've got AAA, AAB, ABA, AAC, ACA, ABB, ACC, ABC, and ACB. This is one set where the first is A. I just did it like that. So if the first is A, you have 9 possible choices. And therefore, we want to figure out the points for each of these. Well, AAA gives you point total of 3, right? Because each times it lands on A, you get 3 points. AAB gives a point total of 5. The next one is 5, 7, 7, 7, 11, 9, and 9. All right? So that's all I did there. I just wrote down the possible outcomes, and then I figured out the points for each outcome. Now let's look at the ones that have B as the first result. The first toss landed on B. And we should be able to do this also pretty quickly. BBC, BCB, BAA, BCC, BAC, and BCA. So these totals, this is 9, 7, 7, 11, 11, 5, 13, 9, and 9. And finally, the outcomes where it lands on C first. So you've got CCC, CCA, CAC, CCB, CBC, CAA, CBB, C. So we've got point totals of 15, 11, 11, 13, 13, 7, 11, 9, and 13. So what is the question asking? It's how many different point totals are possible. Not how many point totals, how many different point totals. So the point totals are 3, 5, 7, 9, 11, 13, and 15. I think those are the only unique ones. 3, 5, 7, 9, 11, 13, and 15. So 1, 2, 3, 4, 5, 6, 7 different possible point totals. So therefore the answer is B. The figure shown is folded to form a cube. 3 faces meet at each corner. If the numbers on 3 faces at a corner are multiplied, what is the largest possible product? So the first step in this question would be to just draw a cube. All right, here's our cube, and I'm going to label the sides. So we'll make 6 as the top right here, and I'll even write that there so there's no confusion. And looking at this diagram, that means 8 will be the bottom, so I'll put that there. And therefore 3 is over here, that side, and 5 will be all the way over there at the very back. So I'll put back there, and this is the front. 3 is the front. And on the sides we have 2 and 7. So 2, I'll just put side, and 7 is this side, left side, right side. So then what they're saying is on each corner, these are the corners, like that. At each corner, 3 faces meet. What is the product of those 3 faces? And then what is the largest product? So for example, let's start with this one here. What are the 3 faces that meet? Well, the top face meets there, the side 7 meets there, and the 5 back meets there. So 5 times 6 times 7 is the product at that corner, and that is 210. They want us to figure out the largest possible product at any corner. So let's just keep going. Let's do this one next. What numbers meet here? Well, it looks like 2, which is the side. We've got 5 as the back and 6 at the top. So that would be 2 times 5 times 6, which is 60. This one here is 2 at the side, 5 at the back, and 8 at the bottom, and that would be 80. And similarly, I hope you understand what's going on so far. This is going to be 3 and 2 and 8. This is 48. This corner here gives numbers 3, 7, and 8, which is 168. And finally, I think we've got 2 more left. This one is 3, 7, and 6, which is 126. And this one is the last one here buried inside. And that one has 7, 8, and 5 as the sides that meet. And that is equal to 280. So I believe that 280 is the largest one. After all that, we finally got the largest one, which is 280, so D. A regular pentagon has all sides and angles equal if the shaded pentagon is enclosed by squares and triangles as shown. What is the value of angle X? So let's draw this out. Okay, so I've just drawn a part of it because that's the only part we really need. Now they're telling you that this is the pentagon right here, all right? And these are squares. And this is, of course, a triangle. And they want you to find this angle X. Well, if these are squares, then this is a right angle. And therefore, this is a right angle. So if we can find Y, we can figure out what X is. Well, the good news is that if you have a pentagon, the sum of the angles is equal to 540. And that isn't even something that you need to really memorize. That's just intuition, because a pentagon can be divided into 3 triangles. And the sum of the angles of a triangle is 180. So if you have 3 triangles, it would be 3 times 180. Okay? So therefore, what is each angle? All the angles of this pentagon are going to be equal, and it even tells you that angles are equal. So there's 5, right? 1, 2, 3, 4, 5. So 540 divided by 5. Therefore, each of those angles is 108. Now, if you look all the way around, the total is always 360, right? So 360 is equal to Y plus 90 degrees, which is this right angle, plus X plus this 90 degrees. And this will help us solve for X. Y we know is 108, and 90 plus 90 is 180, plus X. So if you solve this, you will get 360 minus 288x, and therefore X is equal to 72. So the answer is E. Number 20, 3 playing cards are placed in a row. The club is to the right of the heart and diamond. The 5 is to the left of the heart. The 8 is to the right of the 4. From left to right, the cards are. All right, so we've got 3 playing cards. And we just have to kind of fiddle around with this and see if we can get this to all match based on what they told us. The club is to the right of the heart and the diamond. So I'm assuming the club is here because it's to the right of the heart and diamond. I don't know if this is the heart or this is the heart, but we'll soon find out. The 5 is to the left of the heart. So this is the club. So the heart has to be here, because the 5 is to the left, and there's no other way to put that. So the 5 is here. So that helps us a little bit. The 8 is to the right of the 4. The 8 is to the right of the 4. So this is already a 5. So if the 8 is right of the 4, the 4 has to be here and the 8 has to be there. And that's all we are given. I think we're missing one piece here, the diamond I didn't put in. Well, by process of elimination, the diamond's got to be there. There's no other place. So therefore, from left to right, the cards are the 5 of diamonds, the 4 of hearts, and the 8 of clubs. And of those, I believe B is what gives us that scenario. So the answer is B.